Hello students, how are you? I hope you are doing well. In this video, I have come with three questions from thermodynamics which were asked on the second shift 25th January 2023 JEE mains. So let us discuss the first question here. According to the law of prepartition of energy, the molar specific heat of a diatomic gas at constant volume. Now students, this is very simple and straightforward. The molar heat capacity of a gas at constant volume is nothing but the amount of energy required to raise the temperature of 1 mole of the gas through 1 Kelvin. Again, I repeat, the molar heat capacity at constant volume of a gas is equal to the amount of heat required or energy required to raise the temperature of 1 mole of the gas through 1 degree Celsius or 1 Kelvin at constant volume. This you can straight away remember this formula as Fr by 2, where F is the number of degrees of freedom. So if you know the number of degrees of freedom, you just have to substitute it. Now for a diatomic gas, let us calculate the degrees of freedom. Usually you know that all kinds of gas molecules will have 3 degrees corresponding to translatory motion, 3 degrees of freedom. Then for a diatomic gas, there are only 2 degrees of freedom corresponding to rotational motion. Then corresponding to each additional vibration mode, there will be 2 degrees of freedom. Corresponding to each vibrational mode, there will be 2 degrees of freedom. So altogether you have 7. So CV is 7R by 2. So correct. I hope that is clear. Moving on to the next question. The graph between two temperature scales P and Q is shown in the figure between upper fixed point and lower fixed point. Students, here upper fixed point refers to 100 degrees Celsius, that is the boiling point of water, and the lower fixed point refers to the melting point of ice at 1 atmospheric pressure, which is 0 degrees Celsius. So these two temperatures are taken to be standard temperatures because these are easily available temperatures naturally. Why naturally? Because water is perhaps the most abundant quantity after air. So in that case, you boil water openly in an open condition. Just once the water starts boiling, the temperature is 100 degrees Celsius. Similarly, ice is also available. Plenty of ice is also available in the nature. You keep ice outside, it starts melting. The moment it starts melting, measure its temperature, it has to be 0 degrees Celsius. So water and ice are available in plenty on this planet. So it's very easy to obtain 100 degrees Celsius and 0 degrees Celsius. So that is the concept of upper fixed point and lower fixed point in any temperature measuring scale. Then now we have to convert, or we have to establish a relation between temperature of Q and temperature of scale P. Right. Now here you have to understand, students, one simple thing. Suppose this is a temperature scale. Let us take this as a something like let us say thermometer. Mercury thermometer. Now constant volume mercury. Let us say the volume of mercury is V, and this is the level of mercury at 0 degrees Celsius. Then this is the level of mercury at any T degree Celsius, and this is the level of mercury at 100 degrees Celsius. Now we know that for a liquid, the change in volume is equal to original volume into gamma into delta T. Now this change in volume is nothing but change in length multiplied by cross-sectional area. This is the original length multiplied by cross-sectional area. So area gets cancelled here. So why I have written gamma by 2? So we can see that change in length is equal to original length into gamma into delta t, because cross section area remains constant. Now here, suppose it goes from 0 to T degree Celsius. So the temperature difference is how much? T minus 0. Or I take this as lower fixed point, TL I take, TL. So this will be T minus TL. Whereas this is a higher fixed point, so I'll take it as TH. So for the first expansion from 0 to T degree Celsius, 0 degree Celsius to T degree Celsius, I can write the formula, the equation as, let us take this as delta L1, this portion is equal to original length is this, into gamma into delta T. Delta T is T minus TL. Next, let us consider the expansion from 0 to 100 degrees Celsius, that is from lower fixed point to the upper fixed point. Then if we can write the equation once again, then we have delta L2 is equal to L into gamma into T H minus TL. Now if you divide the equation 1 by 2, then you can see that delta L1 upon delta L2 is equal to T minus TL upon TH minus TL. As you can see, for any thermometer whatsoever, temperature measuring scale thermometer, this ratio will remain same, delta L1 by delta L2. So in other words, this should be constant regardless of the temperature scale, because you can see that we have eliminated the original length of the mercury column and we have also eliminated the gamma of the substance. So now you can replace mercury with any other thermometric substance, first thing. Second thing, the original volume or the length of the thermometric length can be changed whatsoever. So it doesn't matter. So now here let us come to this question. Since this entire thing is 180 and this is 150, so this has to be 30. So for P, temperature scale P, I can write temperature scale at P minus the 0 of P is what? 30. 30 divided by this is the upper fixed point and this is the lower fixed point. So 180 degree minus 30. This should be same as for temperature scale Q. See, TQ minus lower fixed point is 0 because it is starting from here. So it is here. This is 0 for Q. Upon this is 100. So 100 minus 0. So therefore correct answer is the second option. You can see TP minus 30 by 150, this is 150 is equal to TP by 100. So I hope that is clear. Moving on to the next question. You have matched the column from list 1 with list 2. This is very simple, student. Now isothermal process is something which proceeds at constant temperature. So there is no change in temperature, so there is no change in internal energy, because after all, change in internal energy is a function of change in temperature. So always remember, change in internal energy is a function of change in temperature. So A should be mapped to 2. So that means option 1 or 2 could be anything, right? Let us verify which of them is exactly correct. And coming to the next thing, adiabatic process. You know, adiabatic process is something in which there is no heat exchange between the system and the surrounding. No amount of heat is exchanged between the system and the surrounding. So in such case, what happens is, if work is done by the gas, then it will decrease its internal energy. Because no heat is transferred between the surrounding and the system, any work done by the system will result in an equivalent amount of decrease in its internal energy. So B should be mapped to 1. B should be mapped to 1. Then coming to C, isochoric. Isochoric process is one in which the volume remains constant. As we know that the work done is equal to integral P dV. dV is the change in volume. Since for isochoric there is no change in volume at all. So if there is no change in volume, then work done will be 0. So this is fourth. C should be mapped to fourth. Then coming to the last option, that is isobaric process. Isobaric, iso means same, bar is the unit of pressure. It is 1 lakh Newton per meter square. 1 bar is the unit of pressure. It is 1 lakh Newton per meter square. It is usually employed in meteorological purpose, that is the study of weather and climate. So approximately 1 atmospheric pressure is 1 bar. So something isobaric process means in which the heat absorbed goes partly to increase internal energy and partly to do work. Because basically for an isobaric process, whatever heat is supplied, that a part of it goes to increase its internal energy and the remaining is utilized by the gas to do work against the forces due to external pressure. So I hope that is clear. Correct option is second option. Let us move to the next question. All the questions are over, all the 3 questions are over. So that's all in this video, students. Thank you so much.